Welcome back to Critical Minerals Uncovered. Today, we're talking about something so common you probably walked across it this morning, and yet it underpins almost everything in modern civilization. I'm talking about silica, or as most of us know it, sand. Sand is the second most used resource on Earth after water, and while it may look simple, its story stretches from prehistoric mortar and glass beads to semiconductors, solar panels, and the chips that run the global economy. So let's dig in. Silica, or silicon dioxide, is everywhere. It makes up about 27% of the Earth's crust. It's the second most common element. Humans have been using it since prehistory. Early societies mixed it into mortars to build stone structures and melted it into some of the world's finest first primitive glass. Fast forward to the Industrial Revolution, and silica became essential for steelmaking, ceramics, and modern glass. And today, silica sand still underpins construction worldwide. Concrete, skyscrapers, windows, tiles, ceramics. Without it, modern cities would literally not exist. This is why the United Nations calls sand the second most consumed resource after water, with around 50 billion tons mined globally every year. That's an almost unimaginable number, with demand rising around 6% annually. But silica isn't just about cities and concrete. When purified, it becomes something far more powerful, silicon. Elemental silicon is metalloid. It's hard, brittle, blue-gray, and it has a remarkable property. It's a semiconductor. That means it conducts electricity, but only under very specific conditions. And that's why silicon is the heart of modern computing. It's what's made the transistor possible, and it's why we still call California's tech hub Silicon Valley. Chips, solar cells, fiber optic cables, specialist lenses, batteries. Silicon is the foundation of the digital world. The average car today contains over 1,000 chips, each one built on silicon wafers sliced from a crystal grown out of purified sand. The journey from raw quartz grains to the inside of your smartphone is one of the most extraordinary feats of industrial chemistry ever achieved. Now here's the catch. Not all sand is created equal. Beach sand, desert sand, even the sand in your kid's sandbox, none of it's suitable for semiconductors. It's too contaminated, too rounded, or the wrong size. For high-tech uses like chips or solar panels, you need ultra-pure quartz, and that's incredibly rare. The most famous source is Spruce Pine, North Carolina, where some of the purest quartz in the world is mined. Once considered a waste product, this quartz now sells for around $10,000 a ton. That material is carefully blasted, crushed, refined, and chemically treated before it ever reaches a silicon refinery. And without it, the entire global semiconductor industry would grind to a halt. This is where things get interesting and strategic. We may never truly run out of sand, but we can run out of the sand we actually need. High-purity silica is a tiny fraction of the global sand supply, and it's under enormous pressure. Urbanization across Africa and Asia is driving mass cement and glass demand. Solar panels also require high-purity crystalline silicon for panels. In fact, 95% of solar cells today are silicon-based. And then there's the insatiable demand for semiconductors powering AI, EVs, and defense systems. Meanwhile, production is highly concentrated. China controls about 75% of silicon metal supply, and more than 97% of refined polysilicon. Other countries, like Malaysia, Indonesia, have restricted sand exports. Illegal mining is rampant, fueling corruption and environmental damage. So the battle for silicon isn't just about technology, it's about geopolitics, sovereignty, and industrial power. There's also the environmental side. Smelting quartz into silicon requires temperatures over 1900 degrees Celsius, traditionally achieved with coal or other fossil fuels. It's energy intensive and carbon heavy, but cleaner pathways are emerging. Norway, for example, is producing silicon by using hydropower smelters, dramatically reducing emissions. Recycling silicon from solar panels is another growing field. The challenge is scaling these low-carbon solutions fast enough to keep up with demand. From ancient glass beads to quantum computing, silica and silicon have shaped human progress for thousands of years. But here's the lesson. It's not enough to have the raw sand. You need the ability to refine it, to turn it into silicon, and to manufacture with it. That's where most of the value and most of the power lies. So next time you walk on a beach, look down. Those grains beneath your feet may look ordinary, but they are the hidden backbone of civilization. And in the 21st century, the question isn't, do we have enough sand? It's, do we have the right sand? And can we control it? Thanks for listening to Critical Minerals Uncovered. If you enjoyed this episode, follow, share, and join me next time when we'll dig into another material that quietly shapes our world.